So, just a little review for what we talked about over the week. We are doing inequalities, which is like the less than or greater than, less than or equal to, greater than or equal to, that we did probably when you were like back in like 3rd grade. You talked about these things. So when we talk about graphing inequalities on a number line, that's what we're doing right here, there are 2 very important things that we need to do. The first most important thing is to make sure our variable is on the left-hand side, okay, of my inequality. Is my variable on the left-hand side of this inequality? Boom, easy, good to go. We read this left to right, so we're reading this as x is less than or equal to -1. Okay, when we read this left to right, the little side points to the littler, less than, or if you're like back in 3rd grade, the monster eats
the alligator.
The alligator, is that what it was? The alligator eats the bigger number. Okay, that's how you think about it too. I know. Back in the day, like people used to draw little teeth. You know, I'm totally okay if you draw the teeth, whatever. This reads x is less than or equal to -1. The x on the left-hand side, we got the first thing done. Okay? Second thing that we need to do is ask ourselves, is this less than or equal to? This one is a less than or equal to because it has this little bar underneath. Okay? And when that happens, we have to do a closed circle. So we're going to go over here to -1. We're going to make a closed circle. That's a terrible pen. Let's try this one. There we go. It's a closed circle because it's equal to, and then this little arrow points to where my graph goes. So I'm just going to go here. Boom. This represents all the numbers less than or equal to -1. For this problem, number 8 right here, we're going to go y is less than -3. Is my variable on the left-hand side of the equation? Yeah, easy peasy, okay? And this is a less than symbol, so we're going to have an open circle on number 3. So we come here to number 3. It's an open circle because there's not this little bar underneath it. And we need to point to numbers less than 3. Boom. Okay. Pretty easy doing this stuff. Okay. Just ask yourself, is it open or closed? And is my variable on the left-hand side? Easy peasy, lemon squeezy. Okay. All right, looking at the problem that we solved last week, we solved the problem like this. Y minus 5 is equal to -2. Okay, how did I get y by itself over here? Ready?
Yeah.
Add 5 to both sides. Yep, add 5. Add 5, you get y is equal to +3. Easy peasy, right? The same thing happens when we add and subtract up on equalities. So how am I going to get y by itself here? +5, yep. +5, +5. We get y is less than 3. So when we graph that, we have something like this. 3, it's an open circle because it's not equal to, so open, and boom, like that. This is what we did over the week, so you should have these problems already done. This is just getting you guys reviewed and ready to go. How do I solve this problem? Robert? Subtract 2, because it's an addition problem. Subtract 2. We get x is greater than or equal to 5. Is this going to be an open or a closed circle?
Closed.
Closed? Why is it closed, Candace?
Because
It's also equal to. So I have 5, right that. And I have to show what's greater than 5. Boom. All right, cool beans. Think about this sentence right here. Is 4 less than 8?
Yes.
Yeah, right? 4 is less than 8. Okay? If we multiply both sides by 2, so I did 4 times 2 and then 8 times 2, That gives me 8 is less than 16. Is 8 less than 16? Yeah, so that's true. Okay? What about if we multiply by a negative 2? So we get 4 times negative 2, which is negative 8, and then we get 8 times negative 2, which is negative 16. Is negative 8 less than negative 16? Likely you're shaking your head no. So that's false. So we have two properties that we do when we multiply and divide. Okay? The division property of an inequality states that if you divide by a negative number, only if it's negative, you have to flip your sign. Okay, so meaning that if your sign was this, and you divide by a negative, you flip it to that. Okay, you just flip it over. Same thing with multiplication. If you multiply by a negative, only when it's a negative number, not if it's positive, you have to flip your sign. So we're going to move down here to number 5. Okay, we did do that at home. How do we get rid of, or how do we get x by itself here?
Divide by 8.
Divide both sides by 8. Yeah. Divide by 8. We get x. Do we flip our sign here?
No, it stays.
No, it stays the same because this is a positive number. So we get x is greater than 5. Would this be an open or a closed circle? Open. Perfect. Okay. What about number 6? Is x by itself?
Yes.
Yeah?
Well,
No.
I disagree.
No,
because
because it has a negative.
It's got this negative out front. How do we get this negative out of there?
Divide.
Divide by what?
-1.
Divide both sides by -1.
Wow.
Do I flip my sign here? Why is it a yes?
It's a negative divided by.
It's a negative. So we get x is greater than or equal to -4. Do you see how I flip my sign? I just flipped it the other way.
Yeah.
Okay. Lastly, I want to talk about number 7 right here. What do I have to do to get x by itself? Multiply by what?
-4.
Multiply by -4. Both sides by -4. So I get x is, do I flip my sign? Brady, you're shaking your head with yes. Why is that? Because it's a negative number right there. X is greater than -30. Okay. This is just the next page, I think, in your notes packet.
Yeah.
Yep. So when solving an inequality or multiple step inequality, it's the same exact thing as solving an equation. So what we did all of last week. Okay? So when looking at this, okay, is x by itself? Dave saying no. What is my first step?
You would want to subtract 9 or add 9.
I add 9, because this is a subtraction problem. Add 9 to both sides. I get 5x is greater than 30. Does my sign change when I add or subtract? No. Okay? I'm going to divide both sides by 5.
Wait, it wouldn't be 30.
Oh, I added 9 to both sides. Sorry, just the wrong sign. Okay?
My bad.
I'm going to divide by 5 because this is 5 times x, so I got to divide. Does my sign change here?
No.
No? Why not?
Because it's not a negative.
Because it's not a negative. So we get x is greater than 6. Number 2. What is my first step to get y by itself for number 2? Minus 10. Okay? It's a positive 10 over here, and I gotta do the opposite of that. So I'm going to subtract 10 on this side. I get -5y is less than 15. Did I change my sign here? Why not?
Because we're just adding.
We were just adding and subtracting. We don't change the sign then. What do I have to do to get y by itself here, Sam?
Divide.
Divide by what?
5.
5y? Alright, divide this side by 5y. Can I divide 15 by 5y?
Just 5.
Just 5.
Yeah.
Okay? I disagree with that.
Me too.
Candace, what do we want to divide by?
Negative 5.
Negative 5. Okay? Negative 5y. Hey guys. When I divide by a negative, what happens to my sign?
Flip.
Flip it. So I'm going to get y is greater than negative 3. Alright, I want you guys to try number 3 on your own. Michael, how do I put this 7 on this side?
Subtract 7.
Subtract 7 from both sides.
That's where I went wrong.
Okay, so we get,
Same.
there we go. W over 3 is greater than or equal to negative 6. How do I get this 3 off the bottom?
Not good.
Multiply both sides by 3. Do I flip my sign?
No.
Why no, Carly?
It's not
It's not a negative 3. But this is a negative over here. Does that do anything?
No,
No.
it's not on
I don't think so.
It's not what we're multiplying by. So we get 4 is greater than or equal to negative 18. W is greater than or equal to.
And that's
Okay? For number 4. What are you talking about me for?
What? No, not about you.
Oh, okay. Number 4. How do I get my z's on the same side? Add 2.
2z.
What?
Oh, yeah, 2.
Add 2z to both sides. I get 16 is less than or equal to 5z plus 1.
Yeah.
Subtract 1 from both sides, Harper?
Yeah.
So you get 15 is less than or equal to 5z. Now what, Harper? Divide by 5. Divide by 5. I get 3. Do I flip my sign? Less than or equal to z. If I wanted to make this with the z on the left-hand side, because that's something that we gotta do, we gotta practice, that's the same thing as z is greater than or equal to 3. All I did was notice that the big side, where the alligator was eating the z here, so I'd do the same thing for this z over here. Pretty easy to flip that around. Okay? I want you to do number 5 on your own. Alright, what is my first step? This is just me rewriting number 5 up here so you guys can see it. What is my first step for this game?
So what you want to do is you want to times negative 5 by x and then do it to same thing with negative 4.
Yeah, I'm going to do the distributive property. Okay? I'm just going to skip an extra step and do it to both sides. So I get negative 5x minus 20 is greater than or equal to 3x minus 12. Michael, how do I get this x, this negative 5x, onto this side? Add 5x. Add 5x. And I get negative 20 is greater than or equal to 8x minus 12. Now this is a problem that we like seeing. This is easy for us. Okay? What do I get? How do I get this negative 12 on this side? Add it. Yep, it's a negative, so add 12. Add 12. I get negative 8 is greater than or equal to 8x. Zach, how do I get this x by itself? Divide by 8. Divide by 8, and I get negative 1 is greater than or equal to x. Did I flip my sign? Why not?
Why?
This is a positive 8. Okay? This is also read as x is less